Student, today we will learn the chapter differentiation. In this part, we will learn some formulae, derivations of formulae from first principle. Okay. Differentiation from first principle. We will do some questions, formulas using the first principles. Okay. So start with this. Now d by dx of constant function. So we know the formula that f dash x is fx plus h minus fx upon h tends towards 0, that is RHD. Using the RHD we will do. You can solve by using LHD also, but we will do for RHD. Okay, so now adding here c plus h minus c upon, what is h here? y2 minus y1, c plus h minus c. Okay, so we get here h tends towards 0. What we got here? C is cancelled out, h upon h tends towards 0, and we will get here we write here c plus h, not c plus h, c taking common, x plus h to the power 0. Here constant function means constant into x to the power 0, since x to the power 0 is 1. So we can write here c into 1 minus c upon h tends towards 0. Okay, now it is equal to 0 upon h tends towards 0 equal to 0. So differential of constant function with respect to x is 0, right? Now example, if y equal to 2, then dy by dx of differential of 2 is equal to 0. Okay, now next question, if constant functions is occur with any other function, then what we can find out? We can write c fx plus h minus c fx upon h tends towards 0. We take the common, we are getting c fx plus h minus fx upon h tends towards 0, means c f dash x means c d by dx fx. So we can say if constant is with any other function, we first should take the common. Okay, now if the function in addition or subtraction, if there are two functions and we have to take addition and subtraction, what we have to do? Let y is equal to this one, So dy by dx, using first principle, we can write here fx plus minus gx we can write fx plus h plus minus gx plus h minus fx plus h, fx plus minus gx upon h, h tends towards 0. We can write here fx plus h and this minus fx upon h, and plucking plus minus here. Okay, we can write gx plus h and minus plus minus fx upon h, h tends towards 0. Okay, student. So taking this sign here plus minus, we can write here it is f dash x plus minus g dash x. So if here is a plus, then f dash x directly and gx, and we can write here gx. If it is plus, it is minus. So it is the addition formula. Now we can take now some algebraic formulas dy by dx of x to the power n. We can write x plus h to the power n minus x to the power n upon x plus h minus x, or simply h, h tends towards 0. Now we know the formula by limit n using here a, so we can write x n minus 1. Okay, now if we use the formula exponential, that is the polynomial functions x square, x cube and so on, now if we take another formula of e to the power x differential equal to e to the power x plus h minus e to the power x upon x, x tends towards 0. So using first principle, we are writing here, taking the common x, we can write e to the power h minus 1 upon h, h tends towards 0. We can write e to the power x into 1. So differential of ex is itself equal to ex. Okay. This is your formula and this one is your formula. Now take the next formula one. Let a to the power x, we want to find out this differential a to the power x plus h minus a to the power x upon h, h tends towards 0. Now taking again a to the power x common, a to the power h minus 1 upon h, h tends towards 0. We can write this equal to a to the power x into log e base a. So d by dx of a to the power x, where a is any constant. Okay, so we are doing all this formula by using first principle. Now if you want to take the differential of log x. So we can write here log x plus h minus log x upon h. H tends towards 0. This is the first principle, fx plus h minus fx upon h. We are using LRSD. Okay, now using log formula, log m upon n. Log m upon n equal to log m minus log n. Okay, and taking dividing by x, we can write here 1 plus h upon x upon h. H tends towards 0. Now using the limit of this h upon x, it is here is h upon x, h only. We can write this series h upon x minus h upon x square upon 2 plus h upon x cube upon 3 dash 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 upon h. H tends towards 0. Taking h upon x common and cancel out h, we can write 1 minus h upon x upon 2 plus h upon x whole square upon 3. And now putting the limit here, we are finding 1 minus 0 plus 0. The higher power of h will be 0. So differential of log e base x is equal to 1 upon x. Okay, now if we want to take the differential of log of at any base, so first we have to change it log of a base e into log of e base x. Now this one is the constant, so we can take the constant outside common and dy dx of log e base x, and we have found it, that is 1 upon x. So differential of log a base x is log a base e into 1 upon x. Okay, so logarithmic formula, exponential formula and polynomials formula we have already learned, right? Now we will go to the discuss about trigonometric functions. D by dx of sin x, sin x plus h minus sin x upon h. H tends towards 0. Now using sin c minus sin d formula, 2 cos c plus d by 2 sin c minus d by 2. Now we can write this one 2 cos x plus h by 2, 2x upon 2x and h by 2. Okay, and we can write sin h by 2 upon h, taking limit here, and we can dividing by 2 here and multiplying by 2 here. This 2 is cancelled. Now putting value cos x plus 0 by 2, so it is 1. You have already learned in the limit chapters, sin theta upon theta, theta tends towards 0. Okay, so we are getting here cos x. So differential of sin x is cos x. Okay, similarly we are going to be finding of differential of cos x. Now similarly we will do it cos x plus h minus cos x upon h tends towards 0, and cos c minus cos d equal to minus 2 sine c plus d by 2 sine c minus d by 2 upon h. So where we are getting here minus 2 sine x plus h by 2, and here we are getting sine h by 2 upon h by 2, multiplying here 1 by 2, taking limit here, we are finding this 2 is cancelled, minus sine, here is also limit sine x plus, so we are getting minus sine x. Okay, so differentiation of cos x is we are getting minus sine x. Now go to the next differential of trigonometric, that is the 10x. Tan x plus h minus tan x upon h tends towards 0. We are using this way, changing it with sine cos, and then taking the LCM here. Okay, so we can say sin x plus h into cos x and minus cos x plus h into sin x, and here is 1 upon h limit also. Okay, now sin a cos b minus cos a sin b, you know this trigonometry formula, sin a minus b, right? And write here h, and we can write here cos x plus h upon h tends towards 0, and writing here cos x also. So we are getting sin theta upon theta, that is equal to 1. So it is 1 and 1 upon cos x plus 0 into cos x. So differential of 10x, what we are getting here, that is sec square x equal to this one, 1 upon cos square x, so it is sec square x. Similarly, we are going to be next differential of cot x. So we can write again cot x plus h minus cot x. Are you understanding? I think this is the first principle. Okay, change it, cos x plus h upon sin x plus h minus cos x upon sin x 1 upon h. Okay, now taking the LCM here, sin x plus h sin x cos x plus h into sin x minus sin x into sin x plus h, cos x plus into sin x minus cos x into sin x plus h. Into 1 upon h tends towards 0. So we can cos a sin a cos b minus cos a sin b, but we can take the formula sin x minus h. Okay, upon h, 1 upon sine x plus h sine x, h tends towards 0. This is cancelled and here is minus, so which should be multiplied by minus. We can check minus sine minus h upon minus h, h tends towards 0 is 1. Here is sine x plus 0 sine x, so we can write minus 1 into cosec square x. So differential of cot x is minus cosec square x. Okay, now we are going to take the differential of sec x. Now same method, sec x plus h minus sec x upon h, h tends towards 0. We are changing it. Okay, so you are understanding. Now taking again LCM, cos x minus cos x plus h. Are you understanding? Okay, so cos c minus cos d, using the formula cos c minus cos d, 2 sine c plus d by 2 sine d minus c by 2. Okay, so now what we left here, cos x plus h by 2, and here cos sin h by 2. We take h for with this and here, so we can write here sin x plus h by 2, h tends towards 0 into sin h by 2 upon h by 2, h tends towards 0 upon cos x plus h, h tends towards 0 cos x. You can see here. Okay, h by 2 upon h, this h by 2 can taken with this, so we are getting sin x plus 0 by 2 upon cos x plus 0 into, this is 1 and cos x, so we are getting sin x upon cos x, 1 upon cos x, means 10x into sec x. So differential of sec x, we can write here sec x into 10x. Okay, similarly if we are going to be find the differential of cosec x, we can write here again this way using first principle. These all formula we are finding using first principle. Okay, if you are saying find the formula using first principle, then you will do this way. Same method, again we are going to take LCM here. Sin x minus sin x plus h, so using sin c minus sin d, 2 cos c plus d by 2 sin c minus d by 2, taking the minus, h cancel here, h cancel here, and multiplying here minus sin x plus h sin x, taking the limit here, we can find this 2 is cancelled with this, multiplying by 2 and divide by 2, so we are getting here cos x plus 0 by 2 sin x plus 0 sin x into 1 into minus. So we getting here differential of cosec x equal to minus cot x. This one is cos x upon sin s cot x, and this one is cosec x. Cot x into cosec x. So differential of cosec x is also negative. When we are taking the differential starting with c, then it is in negative. This way you can learn differential of cos x, cosec x, cot x in negative. Okay. Now if we are going to take the differential of first principle by the inverse function of inverse functions, okay, so you can find out the differential of inverse function. Now find the differential of inverse function of sine inverse. So let y equal to sine inverse x, therefore we can say sine y equal to x. Okay, so if we want, we will find the differential of sine y, differential of with respect to y. Now we can write it this way: dx with respect to dy equal to differential of sine y with respect to y. Now letter is changed here. Okay, so we are getting here that is cos y, is it? So we can say differential of sine y is cos y, or we can write here dy by dx 1 upon cos y equal to 1 upon under root 1 minus sin square y. What is the y? That is sin inverse x, and sin y is x. So we getting differential of sin inverse x equal to 1 upon under root 1 minus x square. Okay. Similarly, if we want to find the differential of cos inverse x, so let cos inverse x equal to y, x equal to now cos y, so dx by dy equal to minus sin y, so we can say dy by dx equal to 1 upon sin y equal to 1 upon under root 1 minus cos square y. So differential of cos inverse x is 1 upon under root 1 minus cos y is x. So 1 minus x square. Okay. Similarly, we can find the differential of tan inverse x. So let tan inverse x equal to y, x equal to tan y. Okay. So dx by dy equal to sec square y. So we can find dy by dx 1 upon sec square y 1 plus tan square y. So we can find differential of tan inverse x equal to 1 upon 1 plus x square, since tan y equal to x. Okay. Similarly, now we are getting the differential of sec inverse x. First we got the cot inverse x. So cot inverse x equal to y, x equal to cot y. Okay, so dx by dy equal to minus cosec square y dy by dx equal to minus 1 upon sin square y cosec square y equal to minus 1 upon under root 1 plus cot square y. So we can say differential of cot inverse x equal to minus 1 upon 1 plus x square. Okay. Similarly, now we are going to find the differential of sec inverse x. So let sec inverse x equal to y, therefore x equal to sec y. We can find dx by dy equal to sec y tan y. So dy by dx equal to 1 upon sec y tan y. Okay, we can write here sec y under root sec square y minus 1. So differential of sec inverse x equal to 1 upon sec y is x under root x square minus 1. Now go to the next point, differential of cosec inverse x. So similarly, cosec inverse x equal to y. Therefore, cosec x equal to x equal to cosec y dx by dy equal to minus cosec y and cot y. So dy by dx equal to minus 1 upon cosec y cot y equal to minus 1 upon cosec y under root cosec square y minus 1. So we can write this is equal to minus 1 upon x under root x square minus 1. So this way we have find out the basic formulas of trigonometric function, exponential function, polynomial function, addition functions, and now I am going to be tell you differentiations in the next video for product and quotient law. Okay, thank you for watching.